જય હિન્દ દોસ્તો, આપ સૌનું સ્વાગત છે મારી યુટ્યુબ ચેનલ ઉપર. કાલે આપણે મિશન PSI વાયરલેસમાં એનાલોગ સર્કિટના IMP MCQમાં 1 થી 16 ક્વેશ્ચન જોઈ ગયા છીએ પાર્ટ 1માં. આજે આપણે પાર્ટ 2 જોઈશું 16 થી 32 ક્વેશ્ચનનો. ચાલો તો સ્ટાર્ટ કરીએ. Verse 17. What makes up the total current in a semiconductor? Option A, only diffusion current, only drift current, C, drift plus diffusion current, D, drift plus diffusion plus biasing current. Then the answer is C, drift plus diffusion current. Total current in semiconductor means drift current plus diffusion current. Next question, question number 18. The equation Zn is equal to Qn mu n E ampere per centimeter square represents option A, drift current, B, drift current density, C, diffusion current, D, diffusion current density. Then the answer is drift current density. Here Q is the charge on carrier, N is the number of carrier, mu n is the mobility constant, and E is the electric field intensity. These are the factors which comprise the drift current. In the equation represent drift current density. Question number 19. What is the mobility? Option A, as of carrier difference, B, as of current flow, C, as of access to junction, D, as of movement. Then the answer is as of current drift. Mobility means as of current drift. Next question, question number 20. Why does a gradient occurs in semiconductor? Option A, because of current flow, option B, because of diffusion current, option C, because of drift current, option D, because of difference in concentration. Then the answer is D, because of difference in concentration gradient occurs in semiconductor. Explanation is that there is a different level of doping in P and N region of semiconductor. The carrier, either hole or electrons, moves from a region of high concentration to a region of low concentration, giving a rise to diffusion current. Means gradient occurs in semiconductor due to difference in concentration. Next question, question number 21. How does diffusion current produce the depletion region? Option A, diffusion causes the holes and electrons to collect at the junction. Option B, diffusion is because of the depletion region. Option C, depletion region aids diffusion. Option D, the statement is not true. Then the answer is A, diffusion causes the hole and electrons to collect at the junction. Explanation. The diffusion of carrier from one side to another make the holes and electron to collect on either side of junction, creating the depletion region. This is shortened depending on the biasing. Then the answer is option A. Next question, question number 22. Transition capacitance of a diode is directly proportional to option A, area of cross section, option B, width of depletion region, option C, reverse voltage applied across the terminals, option D, drift current. Then the answer is area of cross section, means transition capacitance of diode is directly proportional to area of cross section. Here the equation of transition capacitance is equal to sigma A by W, where the sigma is the permittivity of material of diode, W is the depletion width, and area of A is equal to area of cross section, means directly proportional to area of cross section and inversely proportional to depletion width. Next question, question number 23. As the reverse bias voltage increases, the transition capacitance will be option A, increases, B, decreases, C, does not depend upon the voltage, and D is constant. Then the answer is decreases, means reverse bias voltage increases, the transition capacitance is decreases. As the reverse bias increases, the depletion width also increases, hence the transition capacitance will be decreases. Next question. Question number 24. Diffusion capacitance is larger than transition capacitance. This statement is true or false? Option A true, option B false, option C both are same, option D depend on the doping concentration. Then the answer is false. Means diffusion current is not larger than transition capacitance. This statement is false. Then what is true? Diffusion capacitance occurs in forward bias diodes. The transistor capacitance is easy to see in reverse bias. CD greater than CT for a forward bias junction. In reverse bias though, CD may be neglected compared to CT. मतलब diffusion capacitance greater than CT for a forward bias junction. Question number 25. Ripple factor of half wave rectifier is option A 1.414, option B 1.21, option C 1.3, option D 0.48. Then the answer is 1.21. Question number 26. If the input frequency is 50 Hz, then the ripple frequency of half wave rectifier will be equal to option A 100 Hz, option B 50 Hz, option C 25 Hz, option D 500 Hz. Then the answer is 50 Hz. Ripple frequency of half wave rectifier, half wave. Here the input frequency and ripple frequency of half wave rectifier is same. Then there is here the input frequency is 50 Hz, then the ripple frequency is also 50 Hz. Then the answer is B. Ripple frequency of output and input is same since one half cycle of input is passed and other half cycle is blocked. So effectively frequency is the same. That's where the answer is 50 Hz. Next question. Question number 27. Efficiency of half wave rectifier is option A 50%, option B 81.2%, option C 40.6%, option D 45.3%. Then the answer is 40.6% efficiency of half wave rectifier. Next question. Question number 28. Question number 28. DC average current of a half wave rectifier output is, where IM is the maximum peak current of input. Option A 2 IM by pi, option B IM by pi, C IM by 2 pi, D 1.414 IM by pi. Then the answer is B IM by pi. Next question. Question number 29. DC power output of half wave rectifier is equal to option A 2 IM square upon pi square into RL, option B IM square upon 2 pi square into RL, option C IM square into IM square by pi square into RL, option D 4 IM square by pi square into RL. Then the answer is IM square upon pi square into RL. Question number 30. DC average current of center tap full wave rectifier is option A 2 IM by pi, option B IM by pi, C IM by 2 pi, option D 1.414 IM by pi. Then the answer is 2 IM by pi. Where half wave rectifier DC average current is IM by pi. In the full wave rectifier is 2 times of half wave, means answer is 2 IM by pi. This is the half wave DC current and this is the formula of full wave rectifier. It is the 2 times of half wave rectifier DC current. Question. DC power output of center tap full wave rectifier is equal to option A 2 IM square upon pi square into RL, IM square upon 2 pi square into RL, option C IM square upon pi square into RL, option D 4 IM square by pi square into RL. Then the answer is 4 IM square into pi square into RL. ripple factor of center tap full wave rectifier is option A 1.414, option B 1.21, option D 1.3, option D 0.48. Then the answer is 0.48. Now the question is over. તો આ વિડીયોની લેક્ચરની PDF આપણી ટેલિગ્રામ ચેનલ ઉપર મળી જશે અને ટેલિગ્રામ ચેનલની લિંક ડિસ્ક્રિપ્શનમાં આપેલી છે. થેન્ક યુ.